Okay, so we start with question 1. So the question reads, rationalize the denominator of each of the following. So this is part 1 of A. We have to rationalize the what? The denominator. So how are we going to do this? So in order to rationalize, so we have 2 root 3 minus root 2 over 4 square root of what? Of 3. So when you just have 4 square root of 3 here like this, or you just have a presence of a radical multiplying a number like this, what you do is you multiply by that radical in order to free the radical from what? From the denominator. So rationalizing, we're just getting rid, or we are removing the what? The radical from the denominator. So here it means we're going to multiply by the root of what? Root of 3, even here, square root of what? Of 3, like that. So this is going to be on top. So you have this 3 here. So it will be 3 multiplying by what? By this part here. So you have 2. So the root of 3 multiplied by the root of 3 there just gives us what? 3 like this. So root 3 like this multiplied by root 3. This here is just what? Square root of 9, and square root of 9 is what? Is 3. So we have 3 there. Then you have root 3 multiplied by what? The square root of what? Of 2. So root 3 multiplied by square root of 2. This here is just what? The square root of 6, like that. So here we have square root of 6. Then down there you have 4. Then this root 3 just gives us what? 3, like that. And this here is just going to be equal to, there you multiply, you have 6. Then here, that will be minus root 6, then divided by what? Divided by 12. Okay, so you can end here, or you can what? Divide here like this, such that you have 6 over 12 minus root 6 over what? Over 12. And this just gives us this side to be half, since 6 into 6 is 1, then into 6 into 12, that's 2. So like this, then minus the square root of 6 over what? Over 12. Okay, so like that, you have rationalized. So that's how you rationalize. Okay, is there any question? All right, so let's do the next question.
Sir,
Yes.
why didn't you multiply the numerator and the denominator by 4 square root of 3? Instead, you only got square root of 3.
Okay, so whether you get the square root of whether you get 4 root 3, or just get the square root of 3 to give us the same answer. So let's do it where we use even 4. So we say square root of 3 minus square root of 2. Then we have 4 square root of what? Of 3. So here we multiply, let's say we multiply by the square root of 3 over 4 square root of what? Of 3. So what are we going to have? So on top, you see now you are going to be multiplying the 4 multiplying by the 2. I mean the 2 multiplying by the 4. That there is going to give us that gives us 8. Then this here, square root and square root of 3 just gives us 3, like that. Then the next here, you have what? Minus. Then you have square root of 2 multiplied by 4, root what? 3. So the 4 will be there. Then here we know root 2 multiplied by square root of 2, that's just the square root of 6. And then divided by, then down there you have 4 multiplied by 4, that's what? That's 16. So you have 16, then root 3 multiplied by root 3 just gives us what? 3, like that. So what is this going to be? So 8 times 3. So 8 times 3 is just 24. So 24 here minus 4 square root of 6. Then down there you have what? You have 16 multiplied by 3, which gives us 40 what? 48. 16 multiplied by 16, this gives us what? 48. Okay, so now simplifying this further, we see that 4 can divide into, okay, so let's do this. So 24 divided by 48, like this, then minus 4 over what? 48, then you have root 6 here. So this is going to be Simplifying this, 24 can go into what? Into 24, that's 1, and into 48, that is 2. Volume a bit. Then you have 4 into 4, that's 1. Then 4 into 46, into 48, I mean, that is going to be what? To be 12. So here you just have root 6 over what? Over 12. So you see you get the same answer. But now, so if you multiply only root 3, you avoid getting these big values like this. Instead, you just stick to the what? The small values that we're having. Okay, is there any question now? Are we clear?
Clear.
Okay, all right. So let's do the next one. So next question, you have x over x plus y root y. So you multiply by the conjugate. So the conjugate has a different sign here. So I always want to make sure that this square root of or the radical is to my what? To the right, and not this side to the what? To the left. So if it's written to the left, you write it and write it to the what? To the right, like that, and then get the what? The conjugate. So it will be even same when we're looking at what? The complex numbers. Okay, so here you multiply by the conjugate, which is just x, and the sign there changes. That will be minus the square root of y, even down there, x minus the square root of y. And then here, you're going to have on top, this x multiplies the x there, so you have x squared, then x multiplied by root y, that will be minus x root y. Then divided by, so here we just have x what? X squared. So you square it because it's the difference of two squares. X squared minus, then you have root what? Y squared, like that. So this now gets rid of what? Of this square root there, because this and that there will cancel, and you have x squared on top minus x root y, like that. Then you have x squared, then that is minus what? Minus y is what you remain with. And this is your answer, like that. You have rationalized. Okay. Let's move on to the next one. So the next one, we have x minus the square root of x squared minus 9, then over x plus square root of x squared minus 9. Then here we rationalize by the what? We're rationalizing the denominator, so we multiply by the conjugate in the numerator and in the denominator. So this will be multiplied by x. The sign there will change from positive to negative. Then square root of x squared minus 9 over x minus the square root of x squared minus 9. And this here is going to be equal to, so the x times the x there gives us what? X squared. And then x multiplied by this root of x squared minus 9 will give us, will just give us negative. So that would be, since there's a negative sign there, so negative x root what? X squared minus 9. But then again, when we start multiplying here, you have a negative. So here, after that, you multiply again this negative root x squared minus 9 times this x here, which gives you the same thing here. So meaning this, you add the 2, and then it will just be minus 2x square root of x squared minus 9. I know you guys know how to expand. So then this here, the last one is negative root x multiplied by negative root x. So the root there will go, and you just have plus. Since negative times negative is positive, so plus, then you have what? You remain with x squared minus 9, since the square root there is what is going to go. And then divided by, so down here you're squaring the x squared, since you have x here, then minus the sign there in between, then you're squaring root what? Root x squared minus 9, you square it like that. Okay, so here you're going to have x squared, then, so this x squared and that x squared, you can add them, which gives us 2x squared. Then you have minus 2x, like that, the root square root of x squared minus 9. Then you have a minus 9 outside there. Okay, then divided by, then you have x squared, minus, so this square root and that will go, and then you have a negative sign here. So this negative is going to be multiplying. So negative multiplied by the x squared, you have negative x squared there. The negative multiplied by the negative 9, you have a plus, so it'll be plus 9 there. And this is just going to give us, on top you have x squared minus 2x square root of x squared minus 9, then over, so this here, x squared minus x squared is 0, then you have what? A 9 remain there. And like that, we have rationalized the denominator. Okay. Let's do the next question. So the next question we have is this one here, which is 1 over, then you have square root of 2 plus 1, then you have root of 3 minus 1. So what you do here, you can separate these first, then you come and multiply them later. So you have, I'll rewrite this one first. So I want to write the root should be on the what? On the right side. So I have 1 plus square root of what? Of 2. Then I'll come and deal with this one here a little bit what? A little bit later. So now we have to rationalize this. So you rationalize this by multiplying by the conjugate, which is just going to be multiplied by 1 minus the root of what? Of 2 over 1 minus the square root of 2. So on top, you're just going to have that this is going to be 1 minus the square root of 2. Then down there, you're going to have 1 squared is just 1. Then minus, here is square out the root. By now, you know that you just remain is 2. Then you're going to have 1 minus root 2 over this here. You subtract 1 minus 2 gives us negative 1. Divide the negative 1, you have, so you have negative 1 there, and that will be plus what? Root 2. So let's keep this. We keep this here, the 1, negative 1 plus root 2. Okay, so we raise now this part, and then we go to the next one. We say this here, so I'll write 1 over, so I'll write the root on the right side, so it will be negative 1 plus the square root of what? Of 3. Then I multiply by the conjugate. Conjugate is going to be negative 1, then the sign there changes. That is going to be what? That's going to be a minus root what? Root 3, then negative 1 minus root 3. So on top, you're going to have negative 1 minus root 3. And then down there, you have negative 1 squared. So it will be like this. Squared, that just gives you positive 1. So you have 1. Then minus the root 3 squared just gives you 3. And then here you get what? You just get negative 1 minus root 3. Then down there, you have negative what? Negative 2. So the negatives can divide, then you just have 1 plus root 3 over what? Over 2. Okay, so now that I have that part, what do I do? So you see now they are multiplying, so I bring them back. So meaning I have 1 over what? Over negative, okay, not 1 over, so they're multiplying, so we are going to multiply. That is negative 1 plus root 2, this multiplied by what we've just found there as 1 plus root 3, like that, over 2. So this is what we are going to multiply. Okay, so here it is over 1. So that means down there you have over 2. Then here you have negative 1 multiplied by the 1 gives us negative 1. Negative 1 multiplied by the root 3 there, you get negative root 3. Then this root 2 multiplied by 1, that will be plus root 2. Then the root 2 multiplied by the square root of 3 there, that's just going to be plus square root of what? Of 6. Okay, then I just rewrite this, that rewrite this as root 6 plus root 2 minus root 3 minus 1. I just want the negative to be this other side, then over what? Over 2. And it's like that, you've rationalized. Okay, any question? Okay, so let's do the next one. Okay, so the next one we have okay, let me erase this first. Okay, so next one you have 5 over 3 minus 2 root 3, like that. So I have to multiply now this by the conjugate, which is 3 plus 2 root 3 over 3 plus 2 root 3. So 5 multiplied by the 3 there, you're going to have what? 15. Then 5 multiplied by 2 there, you get 10. So that would be 10 root 3. Down there, 9 squared, 3 squared is 9, since it's 3 times 3. So 3 squared there is what? Is 9. Then minus, then here, what we're squaring is what? Is this. So this is now just going to be 15 plus 10 root 3. Then you have 9 minus, so 2 squared gives us what? 4. Then you have this root and that will go. So you have 4 multiplying by what? By the 3. 4 multiplying by the 3. Since 2 squared, so here you distribute as the laws of indices that we learned. So you distribute of exponents. So you distribute, you have 2 squared there, then you have root square root of 3 there. So this and that goes, then that's 4 multiplied by 3 gives us what? 12. So that would be 12 here. Then you have 15 plus 10 root 3, then over this here subtract, then you just get that is negative 3. And this here negative 3 can divide into 15, that is going to be negative 5, give us negative 5. And then here, that will just give us negative 10 over what? Over 3 root 3. You can write it like that. Okay. So we're done with part A on how to rationalize the denominator. Unless there's any question, we go to part B. So part B is telling us to rationalize the numerator. So the same thing we were doing, we just now do it in the what? In the numerator. So now you have square root of 5 plus h minus 3 over h. So you multiply by the conjugate. So you can write it like that or just go direct. So let me I write this side, square root of 5 plus h like this over h. Okay, so you write it like this or you just go direct, say I change the sign. So this then is going to just give us, so rationalize the sign here is that's going to change, that's negative. So it'll be negative 3 minus the 5 plus h down, then down there it will be the same like that, 5 plus h. So that gives us, on top you're going to get negative 3 squared gives us 9. Then you have minus the root there, meaning will go, you have 5 plus what? Plus h. Then down there you have, what you're going to have is, so negative, you have negative 3h. Then the h multiplying by that, you get negative h root 5 plus h. Then on top there, this minus that gives us 4. That gives us 4 plus h. Then over, down here you can factor out a negative. So factor out the negative and you just have 3h plus h root 5 plus h. And you close, divide that negative, you have, this will give us negative 4 and, okay, did we do that right? Oh, we didn't multiply the negative by what is here. So, okay, let me erase this part. Go back here a little bit. So here it's minus, but then we have root what? Root 5 plus h squared, right? So this and that go. And then what you remain with here, what you remain with is just the 5 plus what? Plus h. So it distributes, the negative goes to the 5 and to the h also. So meaning that this h here is what? Is negative. So that is negative what? Negative h there. Okay. So now dividing by that negative, you're going to have that will be h, then becomes positive, then the 4 becomes negative like that. Then down you just have 3h plus the h root 5 plus h. Okay. So that's how we rationalize that. Okay, let's do the next one. So next question, you have square root of 3 plus square root of 5, then over what? Over 5. So the conjugate, since you're rationalizing the numerator, the conjugate of that in the numerator, square root of 3, the sign there will be square root of 5 over square root of 3 minus square root of 5. Then you have, so this here just gives us 3 minus what? Minus 5 on top. Then down there, you have 5 multiplied by that. So you have 5 square root of what? 5 square root of 3 minus the 5 square root of what? Of 5. And this is going to be equal. That gives you negative 2 on top. Then you have 5 square root of 3 minus 5 square root of what? Of 5. Can even factor out that 5, just write it outside that you have 5 square root of 3 minus square root of what? Of 5. Okay, like that you've rationalized that one. Okay, let's do the next one for this part. So the last one for this part, you have the square root of x squared plus 1 minus x. So they're telling us to rationalize the numerator. So we know that we can write this, divide this by 1 like this. We can write it as a fraction like this, such that when rationalizing the numerator, we just multiply by its conjugate here, which is just going to be the sign there, which will change. Then you have x squared plus 1, then plus x. Then down there also, the square root of x squared plus 1 plus x, like that. Then you have on top, you're just going to have x squared plus 1, like that. Then minus what? Minus the x squared, like that. Then over, down, that would be square root of x squared plus 1 plus x. And this gives us, so this and that, they subtract, and you have 1 over the root of x squared plus 1 plus x. Okay, and just like that, you've rationalized the numerator. Okay, I don't know if there's any question before we move on to the next question. Right, so the next one, we have this here. They're telling us express the root of 3 plus 1 over square root of 3 minus 1 plus square root of 3 minus 1 in the form A plus B root 3, where A and B are what? Rational numbers. So where A and B are rational numbers in that form. So let's do that. So the first part, you have root 3 plus 1 over what? There you have root 3 minus 1. So what you do to get it in that form, you have to rationalize the denominator first. So we consider this first part here. So I'll rewrite this as root 3. Okay, I'll write this as 1 plus root 3, then negative 1 plus what? Root 3. Then I rationalize the denominator. So you rationalize the denominator multiplied by the conjugate. So this here becomes minus root 3, then over negative 1 minus root 3, like that. Then this is going to be equal to, so you have 1 multiplied by the negative there, negative 1. That becomes, your answer is negative 1. Then 1 multiplied by negative root 3, that would be negative root 3. Then this multiplied by that gives you negative what? Root 3. Then the last one there gives you negative what? Negative 3. Then divided by, this will be 1, since negative 1 squared is 1, minus, then the root goes, then you have a 3 there. Okay, then here you have this, you can add them, and also you can add the what? The negative 1 and then negative 3. And that gives you negative what? Negative 4. Then there you get negative 2 root what? Root 3. Then divided by, here divided by negative 2. So 1 minus 3 is negative 2. Then you can divide this by the negative 2. That gives us what? So that gives us 2 there plus, so that will be 1. Negative 2 divided into negative 2 is 1. Then you need to be positive. Then root what? Root 3. So this is what we get for the first part. Then we just add these other parts there. Is that a question? Okay. The person, are you asking? Or what? Okay, so we continue. Then you have that part, the 2 plus root 3. Then you add the other part, this one here, which is the root 3 minus 1. And this here gives you 1, since 2 minus 1 is 1, plus you add the 2 here, they just give you 2 root what? Root 3. So you've expressed it in the form a plus b root 3, where a and b are rational numbers. 1 is a rational number, 2 is a rational number, because they all can be expressed in the form a over b, where of course b is not equal to 0 and they are co-prime. So you can write 1 as 1 over 1. You can write 2 as 1 over 2. So it can be expressed in that form. Okay, let's look at part B. So part B is still asking about the same. So we do the same even for it. We have 5 over 3 minus 2 root 3. And then we multiply by the conjugate. So that is going to be 3 plus, it becomes plus now 2 root 3 over 3 plus 2 root 3. And this here is going to be equal to 15 there. And then 5 multiplied by that gives us 10 root 3. Then down there you have, that would be 9. Then you have minus, so 4 multiplied by 3. 4 multiplied by 3 gives us 12. And we just have, this is going to be equal to 15 plus 10 root 3. I think we solved this question. And then you have negative what? Negative 3. Divide the negative 3 and you're going to have negative 5 there. Then minus 10 over what? Over 3 root 3. So you have your root 3 there. And you have these here, negative 10 over 3. And the 5 are the rational what? Numbers. Okay. Unless there's any question, but that's how we do this one. Move on to the next one. All right, so the next one, you have this question here. And so this question is asking us to write each of the following in terms of what? In terms of I, and then perform the indicated operation and what? And simplify. So in terms of I, so I is, so this I they're talking of is the imaginary what? Imaginary number. Imaginary number, or complex number represented by what? By I. So what does this mean? So we've been looking at the real number system, where we have everything real numbers. But then there are things that we can't evaluate. So for example, when you have a negative under the root, how do you find that? Because you know that how we get, for example, how you would get, if you say you have this square root of 2 gives us what? Gives us 2. And then the one with a negative, how do we obtain this one? Because we know that to get, for example, the way we got 4, we were multiplying 2 by what? By 2. And of course, we know when we multiply negative numbers like this, they'll give us what? A positive also. But how do we handle such a case? That's where now we can use what? The complex numbers. So what this is it represents the square root of negative 1 is equal to what? To I. Square root of negative 1 is equal to what? To I. Then there, so here, look, when you square it, negative 1 squared, I square even the other side like this. So this just gives me what? Negative 1, like that, negative 1, since this and that cancels, and this is going to be equal to I squared. So I squared is equal to negative 1. So this is what is important for us to know, plus what we learned earlier on what? On radicals. So now let's handle this question. So the first one here, they're telling us there's negative root 4, then negative what? 16. So now you can write this negative 4 as, you can write it as negative 1 times what? Times 4. And you can write this also as negative 1 times what? 16. Then you know by the radicals that you can write this as negative 1 as root of negative 1 and square root of what? Of 4. Then here you can write square root of negative 1, square root of what? Of 16. So this here gives you what? I, as we have seen there. So that will be I. Then square root of 4 just gives you what? Gives you 2. So this gives you what? 2. So I'll write my 2 there. So this is multiplying by what we get there. So here you have square root of 16, that's just 4. Then this negative I here, negative 1 gives you what? I. So you have 4I there. Then multiplying the 2, you just have that is 8I squared. Then the I squared is what? Negative 1. So meaning you have negative 1, that gives you negative 8. Okay, like that. Okay, is there any question how we got our answer? Okay, so let's do the next one. So next you have root what? Root 25 and negative root of what? Of 9. So going directly, as you said, negative what? 1. Then you can write this as negative 5, negative 1, and root 9 like that. So this gives you what? 5I for this one. And then there it will give you what? 3I. And this here is just going to be 15I squared. That I squared is negative 1. So that gives you negative 15. Okay. Next you have square root of negative 36 over square root of negative 4. That gives you, so that will be negative 36, negative 1, root of 4, root of negative 1. This there gives you square root of 6. That's just 6. Then the negative I is, I mean the negative root of 1, that's I. Then you have there, you get 2 and then I. You can divide this and this just divides to give us 3. So answer is 3 there. Okay, next one. You have square root of negative. So you have 64 over square root of negative 16. So this gives you root 64, negative 1, like that. Square root of 16, square root of negative 1. This is going to be 8I over 4I, and this gives us 2. Okay, so that's how we find this one. All right, unless there's any question, we move on to the next one. All right, so next we have this. So telling us find each of the following quotients and express the answer in standard form. Find each of the following quotients and express the answer in standard form. So the standard form of the complex number is A plus B I, like that. So where this is the real part and then this here is the imaginary what? The imaginary part. So they want us to express them in this standard form. So for A there, for A we have 3 minus 5I, then over what? 4I. So how can we express this one standard form? So you just divide by the 4I, each part by 4I. So you have 3 that by 4I, then minus the 5 over 4I, like that. Then what is this going to be? So, oh, there's I here. So this here, the I and the I divide, then you just remain with what? You remain with that, this becomes 5 over 4. So you remain with 5 over 4. Then you have your what? You have your I that is there. So now here, okay, let me write this. So I write the negative 5 over 4 in front. Then here I have that will be plus 3 over what? 3 over 4 I there like that, negative. But the standard form, the I is what is up there. So the I is up and not down here. So what do we do? So you multiply by the conjugate. So the conjugate, so I, like that, the conjugate of I is negative I. So multiply by negative I, then I'm going to have down there. So I only multiply this part here that has that. So that will be 1 over 4 here comes. Then multiplying that, so you have 3 over 4 I multiplied by the I squared. So I mean multiply by negative I. There, even there, negative I. So the up you get negative I like that. Then down there you're going to get, so this will be negative I squared. So it will be 4, then minus I what? I squared. But what is I squared? I squared is just negative 1. So we have 3I over, then you get 4 there. 4, then the I squared is negative 1. So this here gives you what? Positive 4. Then you just remain with 3I negative over what? Over 4. So meaning this is going to be negative 3I over what? Over 4. So we've expressed it in the standard where this is the real number and that part is the imaginary part. That's the real part and that's the imaginary part. Okay, is there any question? Okay, so let's do the next one. So next we have 4 plus 7I like that over 2 minus 3I. So we have 4 minus 7I, 4 plus 7I over 2 minus 3I. So how do we write it in the standard form? So to write this one in the standard form, you have to multiply here, since we have this real part here, the real part is not 0. So you have to multiply by what? You have to multiply by the conjugate. You have to rationalize this. So you have to rationalize this, and then you are multiplying by the conjugate there. So the conjugate is going to be, this sign here will change to positive, and you have this plus, plus 3I over 2 plus 3I. Okay, so something that I want you to see down here going forth, because we'll just be using this. So you have 2 minus 3I. Let me get it here. And then I have 2 plus 3I here. So this here, if I multiply 2 by 2, gives me what? Gives me 4. Then this 2 times that there gives me 2 times the 3 gives me, that gives me 6. That's positive. That gives me 6 what? 6I. Then this here gives me negative 6 what? I. Then there and there you get negative 9I squared. Then you have 4. This and that becomes 0. Then minus 9I squared. But what is I squared? I squared is negative 1. So I replace there with negative 1. And this here becomes positive. So you get 4 plus what? Plus 9. So 4 plus 9, and 4 plus 9 is just 4 plus 9 is just 13. So now what I want you to note is, so this is the same as saying you square this and you square that. So that is 2 squared plus 3 squared. So 2 plus 3 squared. That's the same as saying 2 plus what? 3 squared. And that here you get 4, and that you get 9, and then when you add, you get what? You get 13. So that's what we'll be doing. So when you just see down there multiplying by the conjugate, just square that, and we get our answer, instead of doing the whole thing, the whole process like that. Okay, so having established that, here on top, you multiply the 4 by the 2. The 4 by 2 just gives us 8. Then 4 multiplied by 3I. that is going to be 12i, so that will be plus 12i. Then you have 7 multiplied by the 2, that will be plus 14i. Then 7 multiplied by that there, 3i, so that will be plus 21i squared. Then over here we said that will be just 2 squared plus 3 what squared. And this is going to be equal to, so you add the 2 here. When you add the 2, you have 8 there. Then, but you add these 2, adding the 2, 12 plus 12 plus 14, that gives us 26. So that will be plus 26i, like that. Then you have plus 21 I squared. So down there you get 4 plus 9. But what is I squared is negative 1. So this becomes negative 21. So that will be 8 minus what? 21 plus 26i over what? 13. So 8 minus 21 gives me negative 13. And this is going to be negative 13 plus 26i over 13. So I can divide this 13, and then I'll just have negative 1 there plus 13 there goes 2, so that will be 2i. And I have written it in the standard what? In the standard form. Okay, is there any question? Right, so next one. Okay, so the next one, we have 3, then 7, what? 7i. So I write that there, 4 goes this side, so I have 4i this side, then plus what? The 2 there comes. So even here we go, it's the same approach where you have to rationalize the denominator by multiplying by the conjugate. So the conjugate is 2 minus 4 what? I over 2 minus 4i. And this is going to give us 3 by 2 gives us 6. 3 by the negative 4 gives us negative 12i. Then negative 7 by 2 gives us negative what? 14i. Then there it gives us plus 28. So that will be 28 what? 28i. Then down there, square the 2. So 2 squared plus what? Plus 4 squared. And this is going to be, so there's a square here. It's I squared. Then you have 6. Add the 2 there, you get negative what? 26i. Then this negative here, this is I squared, but I squared is negative 1. So to multiply by the 28, that becomes negative 28. Okay, then down there, 4, you have 4 plus 16 squared, that's just, 4 squared, that's 16. Then you have, this is going to be equal to 6. So 6 minus 28, that just gives us negative 22. So that would be negative 22 minus 26i. Then down there, you have 4 plus 16, which is 20. So 4 plus 16, which is what? Which is 20. So we can now then simplify this. So how do we simplify? We say you now divide negative 22 over 20, then minus 26i over what? Over 20. So this is now going to give you, I divide by 2. So 2, I'll have 2 into 22 gives me 11. Then there, into 20, it gives me 10. Then minus into 26 gives me 13. Then into what? Into 20 gives me 10. And then I have my I. So I've written it in the standard form. Okay. We go to part D. So part D, you have 1 plus square root of, okay. So you have 1 plus square root of 2i. Then you have 3 minus 2i. Multiply by the conjugate, that is 3 plus 2i. Then you have 3 here plus 2i. Then you get on top there 1 multiplied by the 3 gives me 3. Then 1 multiplied by 2i gives me 2i. Then this root 2i multiplied by the 3, you get that this will be plus 3 root 2i. 3 root 2i. Then you have here you multiply this 2 multiplied by the 2i. So root 2 multiplied by 2i, that would be plus 2 root 2 I squared. 2 root 2 what? I squared, like that. Okay. So then from there, we are then going to say over. So over what? So over here you have 3 squared plus what? Plus 2 what? 2 squared. So then this is going to give us, on top you have 3, then you have plus, so 3 plus 2i. You have 3 plus 2i there, and then plus 3 root 2 what? Root 2i. Then this I squared becomes negative. So that's negative 2 root what? Negative 2 root 2. So this is what you have. Then over, then that is 9 plus what? Plus 4, which is just 13. So we are going to get, so what I'll do, I'll group the real numbers, or this and that, and the imaginary numbers, like that. So you have 3 minus 2 root 2, like that. Then the other part, that's 2, and this there, then that is just going to be plus. Okay, so that will be plus 2 plus 3 root 2, then the I there, then over what? Over 13, like that. So over 13 there. So this here is what is going to be what? To be, so in the putting this then in standard form, you divide now. So meaning you have 3 minus 2 root 2, like that. And then over 13, then plus. So plus, then you have what? 2 plus 3 root 2 there, over 13, and then you have your I, of course, there. So you can put this like that, or just put the I there. So this here is our standard form. Okay, let's do the last one, which is E. So E will do this, and we do that, and then we just come and what? Add the two. So the first one, we have 1 plus 2i over 1 minus I. So the conjugate of that is going to be 1 plus I over 1 plus I. Then this is going to be equal to, so 1 times 1, 1. Then the 1 by the I gives me I. Then 2 by 1 gives me 2i, like that. Then 2i multiplied by I, 2i multiplied by I, that is just going to be 2i squared over 1 squared is 1, and also 1 squared is what? Is 1, so that will be plus 1. Okay, then you have, this is going to be, I can add these two, so that will be 1. Adding the 2, I'll get, that will be 3 what? 3i, and this here become, that will be, this, since it's negative 1 multiplied by the 2 gives us negative 2. Then over, add 1 plus 1 is 2. Then you get this part. So this minus 1 minus the 2, that 1 minus 2 gives me negative what? Negative 1. So you get negative 1 plus 3i, then over what? Over 2. So I'll keep it like this for now. Then we go to the next one. So the next one, you have 1 minus 2i, then over 1 plus 3i. Multiply again by the conjugate, so the sign there changes to negative 3i, then there 1 minus 3i. Okay, so this is going to be equal to, on top, you have 1 multiplied by 1 is 1. 1 multiplied by that, 3i gives you negative 3i. Then negative 2i multiplied by 1, that gives you negative 2i. Then this by that gives us positive, that is going to be positive 6i squared. Then over, that is 1 squared is just 1. So okay, let me write it as 1 squared. Then plus 3 what? 3 squared. And this here is just going to be equal to, so the I squared there is negative. So the right is negative 1, negative becomes negative 6. And you have 1 minus the 6 there. Then you add these two. Adding the 2, you get negative 5i. Then down there, you have 1 plus 9. And this is going to be equal to 1 minus, so adding, so not 1. So when you subtract 1 minus 6, that gives you negative 5 minus 5, minus 5i. Then over what? Over 10. Over 10. Then I can simplify this. Since 5 goes into both of them, I'll have negative 1 over negative what? 5, negative I mean, negative I, since it's ones, then over what? Over 2 there. So 5 into 10, that's 2. 5 there, 1. 5 there, 1. Then you remain with 1 minus I over 2. So now let's just add them, because you're adding the 2. So what we found at first and that, so at first we had this negative 1 plus 3i over 2, then plus, so we're adding what? Plus this other one, which is negative 1 minus I over what? Over 2. So what we can do, since they have the same base, keep the base, and then you add what is in the what? In the numerator. So in the numerator, you have negative 1 minus 1, like that. Then you have plus 3i minus I. And this is going to be, you add the 2 there, you get negative 2. Then 3i minus I gives me what? 2i. So that would be plus 2i over 2. Dividing there by 2, you just get negative 1 there plus I. Negative 1 plus I. And we've written it in the standard form. Okay, so that's how we answer this question. Unless there's any question. Okay, so let's do the last parts for this class. So the last part is here. The last part is telling us to plot each complex number and find the absolute what? The absolute value. Plot each complex number and we find the absolute what? The absolute value. So now a complex number is z is equal to what? To a plus b what? Bi. A, others all could be written also as x plus what? Yi, like this. Z is equal to x plus yi. And then the absolute value of this is just equal to the square root of x squared plus y squared. That's the absolute what? The absolute value of the complex number. Then the conjugate, which is denoted like this. This is, so z now with a bar would mean the conjugate. Z with a bar means the conjugate, meaning the sign there will change to negative, like that. So that is going to be what? The conjugate, or that is what is the conjugate. Okay, now they're telling us what to plot. So when plotting the complex number, you're going to consider it in this form, where you say x and what and y. And then what we are plotting, so on y, that is the imaginary what? The imaginary axis. So y is going to be the imaginary axis. And then x is the real axis. X is the real axis there. So now let us plot. Having put this in mind, let's plot and find absolute what? Values. So let's start with the first one. So this is, we have 3 plus 4i. So 3 plus 4i. So identifying that, so meaning this here, our 3, which is the real part, is x, and the 4 there is what is our y. And so you put it like that, where you say y, this here is the imaginary what? Imaginary axis. And then your x there is the what? The real axis. Real axis. Okay, so now your x, in your x you have 3. Let's say 3 is here, and there we have 4. We say our 4 is there, like there. So you start from the origin. You draw a line from the origin like that up to where your point is, like that. So this here is uh that complex, what? That complex number. And you can write 3 plus 4i, like that. That's our complex, what? Our complex number. So now, after writing that, they're telling us to find the absolute value. So meaning they're telling us to use this here to find that absolute value. So what are we going to do? So we'll say this is going to be equal to, so you see now, um, it absolute value of our complex number, which we're saying z, our x, in this case is 3. So you say 3 squared plus our y is 4, that's 4 squared. And this is going to be equal to, then you have 9 plus what? 16. So 9 plus 16 is just 25. So this is going to be square root of 25, which just gives us 5. So that's your absolute value there. That is your absolute value. Okay, so let's do the next one. So the next one, you have b, which is just saying 4. So b is saying -4. So if it's -4, so -4 is the real what? The real number. So that's the real part, meaning the imaginary part is what? Is 0. So you have 0 what? 0i. Meaning what you're plotting the point -4, comma what? Comma 0. -4, comma 0. So you go there like that and that. You have your y, you have your what? X. So -4, let's say 4 is there, -4 is there, and then so in the y-axis you're moving what? 0 step. So meaning it to be just at that point, meaning to start from the origin going up to there like that. So this here is going to be your complex number, which is just -4. And then your absolute value is going to be equal to square root of, so you have -4 squared there plus your x, your y is just 0. So write 0 like that. And this here is going to be 4 squared. That's just our 4 squared is 16. So 16, and then 16, the root of 16 is just 4, like that, which makes sense, because if we only have you put this -4, which is that as the only what, the absolute value there is going to give you what? It's going to give you 4, since you always get a positive what value from there. Okay, let's do the next one. Next one, we have -5i. So -5i means that our real what? Our real part is 0, meaning we're plotting the point 0, comma -5 there. So you get y, and you have x there. So in the x, we're moving 0, but in the y, 5. So let's say -5. Okay, so it's down here. So let's say our -5 is there. So meaning you're moving from 0 here to there, and you draw a line there, and then that is your -5i, which you're talking about. Then you say, again, absolute value there is going to be 0 squared plus minus 5 squared, which is just going to give us 25, which is just giving us 5. So that is how we do it. Next. Okay, so next we have 3 minus 2i. So 3 minus 2i. So x and our y is there. So we're plotting 3, comma -2. Okay, this is going to be that. So x, this is our y, that's our x. So our x is what is 3. So there are 3, and our y is -2. Let's say -2 is here. So that point there is okay. Miss that. So like that there. So this here is going to be our complex number, which is 3 minus 2 what? 2i. Then our absolute value is going to be equal to square root of, so x, that's 3 squared, plus our y is -2 squared, and this here gives us 9 plus 4, which is just 13. So you get the root of what? 13. But this has no perfect square, so we just leave it like that there. Okay, we move on to E. Okay, so we move on to part E. So part E, you have 1 over 2 plus I, and then you have root 3 minus 2i. So what we can do here, we can get them as we did in the first example, where we rationalize them step by step, then we put them together, and then we come up with what? We write it in standard form, our complex number in standard form. So this here is going to be, so I'll start with the 2i, 2 plus I, like that. So this 2 plus I, what is it going to give us? So we multiply by the conjugate, both in the numerator and in the denominator. So you have that there, 2 minus I. So this is going to be 2 minus I over, down there you get 4. So that's 4 plus what? Plus 1. And this here is going to give us 2 minus I over what? Over 5. So we keep this, and we say the other one is 1 over square root of 3 minus 2i multiplied by the conjugate, that would be root 3 plus 2i over square root of 3 plus 2i. Then on top, so you have root 3 plus 2i. Down there, you're going to have the root there goes, you just remain with 3, then plus what? Square root of, so you square 2, that gives you 4. So this here will give you what? 7. So you have root 3 plus 2i over what? Over 7. And these are multiplying, as you can see, it's multiplying. So we get the first part, which is 2 minus I over 5, then multiplying by root 3 plus 2 what? 2i over what? Over 7. And this gives us, down there you get 35. Up you have, so 2 multiplied by the root 3, so you get 2 root 3. 2 multiplied by 2i, that gives us 4i. Then negative I multiplied by that there gives us negative 3i, like that, negative root 3i. Then negative there multiplied by that gives us 2, negative 2i squared. Okay, so from here we're going to have this is going to be on top there. You see this negative I squared, this source is going to be, I mean this I squared is going to be -1 multiplies by that gives us positive. So that would be a positive 2. So you have 2 root 3 plus what? Plus 2. Then on the other side, you have plus 4i minus root 3 what? Root 3i over what? Over 35. Okay, so now dividing this by 35, so you have root 3 plus 2 over 35, then there plus 4 minus 3i, like that, over what? Over 35. Okay, so this is what you have. You've written it now in what? In standard form. Now you can what? You can graph. Now you can graph this. So what is this? So 2, so so if I compute this here, this part, which is the root part, x, on a calculator, so you have 2 root 3 plus 2, then you divide by 35. That is going to give, okay, let me do that again, 2 root 3, then plus 2 divided by 35, you get something like 0.156. So this gives us that approximation. Then let's see for the other one. The other one, you have 4 minus root 3, like that, then divided by 35. So that gives you another smaller number, which is 0.065. So this just gives you that approximation. So you have this. So this is y. So you have y here and you have x. So they are both positive numbers. So say our x will be somewhere here. So that is going to be our 2 root 3 plus 2 over what? 35. Then on the other side, this one here is smaller, so you expect it somewhere here. And then that is our 4 minus root 2 minus root 3 over 35. Okay, so then this part is where the point is. So you write the line up to there like that. And that is your complex number. So you've plotted it. Now let us find the absolute value for it. So the absolute value, what is that going to be? So erase this here. Our absolute value is going to be, so we said, okay, for a complex number, you get your y to be root, then you get your y. So you get your x, so you x, then you square your what? You square your x. So that is going to be 2 root 3 plus 2 over 35 squared, like that, then plus negative 3 plus 4 there over what? Over 35, then you square that. And what is this going to give us? What is this going to give us? So on top there, you're going to have, okay, so this is going to be equal to, so if I square this here, so on you just have 2 root 3 plus 2, then squared. So then when you square 9, that's 9, I mean 35. 35 squared gives us, this will be 1 over 1, 2, 2, 5. Then you have plus negative 3 over 4 squared over the same value, 1, 2, 2, 5. Okay, so this whole thing is in a square root like that. Now, you know by the rules of Surds that you can separate this. It's the same. Okay, there's addition there. Oh, I didn't see that. So, okay, after having this now, you can expand what's on top for each and every one of them. So there's a square root there like that. Then on top, this root 2 root 2 plus 2 is just me multiplying by itself. So meaning I'm multiplying 2 root 3 plus 2 times 2 root 3 plus 2. So what does this give me? So this is going to be 2 multiplied by this part, you get 4 multiplied by the 3, that gives us 12. Then this multiplied by 2 here, so 2 multiplied by that gives me 4, so you have 4 root 3. Then this multiplied by that gives me also 4 root what? Root 3. So 4 root 3 like that. Okay, then the last 2 times 2 gives me 4. Then you're going to have this to be equal to, so 4 plus 12, that gives us 16. So you have 16 plus 4 root 3. So you add this, I mean 4 times 4 gives, 4 plus 4 gives us 8. So you have 8 here, 8 root 3. Okay, so that's for the first one. So I write that 16 plus 8 root 3, like that, then over 1, 2, 2, 5. Okay, then let's expand that one there. So we're expanding negative root 3 plus 4, like that, negative root 3 plus what? Plus 4. This is going to be, so you multiply the 2, that gives us positive what? Positive 3. Then multiply by that, it gives me negative what? Negative 4 root 3. Multiply by that, it gives me negative 4 root 3. Then 4 multiplied by 4 gives me what? 16. So that'll be plus 16. And this here is going to just give us 16 plus the 3 gives me what? 19. And then adding these two here, I get negative what? Negative 8 root 3. But it's also over this 121. So we bring it here. So this is just going to be plus 19 minus 8 root 3 over 1225. Since, yeah, 1225. Okay, then from here now, let's erase this. Let's erase this. Since they have the same base, I can keep that base. So this will be equal to square root. The base there is going to be 1, 2, or they have the same denominator. 1, 2, 2, 2, 2, 5. Then I can add what's in the numerator. So I have 16 plus 19, like that. Then this 8, so you have plus 8 root 3 minus 8 root 3, which becomes 0. But adding that to, so 16 plus 19, I get 35. So this will be square root of, so on top there, I just remain with 35 over 1225. This is going to be, I can write this as root 35 over so the square root of what? Of 1225. So this gives me square root of 35 over that square root is just 35. So this here is the absolute value for this one. So this one was long. Okay, is there any question before we do the last question? All right, so the next question, the last question here. So you have 5 minus 4i, then plus the 5 over 3 minus 4i. So we just consider first the 3 minus 4i, and I rationalize this, and I'll just come and add it to that. So rationalizing, I multiply by the what? By the conjugate, that's going to be 3 plus 4i, then over 3 plus 4i. And this is going to be equal to, that's 15, 5 times 3 is 15, then 5 times 4, that's 20i. Then down there I have 3 squared plus 4 squared, which just gives me 15 plus 20i over 9 squared, 3 squared, that's 9, plus 16, which just gives me 25. Then I have 15 plus 20i over what? 25. So that gives me what now? Can divide by 5, and I'll have, so 15. So dividing 15 over 25 plus 20i over what? 25. So this is going to be 3 there, then there 5. If I divide by 5 plus 4 there over what? Over 5i. Then I have this part here now, which I'm going to add, which is 5 minus 4i. Then you're adding plus this 3 over what? Over 5 plus 4 over what? Over 5i. So the real part, which is 5, and this 3 over 5 will add. So I'll add the 3 plus 3 over 5, and then I'll add also that negative 4i plus 4 over 5 what? I, like this. So I end up, so you have 5 plus 3 over what? Over 5. And that gives us, so when you add that, you get 28 over what? Over 5. Then the other one, you have the 4 over 5, then minus the 4, which just gives us negative. So that would be negative 16 over 5 what? Over 5i. So I've written it first in that standard, so I know now what am I going to what? What am I plotting? So what you're plotting the point that is 28 over 5 comma negative what? 16 over what? Over 5. So this 28, so 28 divided by 5 just gives us 5.6. That's this one there. Then 16 divided by 5 is 3 point what? So you get negative 3.2. So those are the approximations you have. Anyway, it won't even matter whether you know them or not. So you have the imaginary part, the imaginary axis y, and then x as the real axis. So 5.6 is maybe somewhere here because it's big. So you write there it as 28 over what? Over 5. Then negative what? Maybe somewhere going to be here, negative 3.5, which is just the 16, negative 16 over 5. Then you have it here like that. And then you just draw what? You draw a line from the origin to that point there. So that there is going to be our, this number here, or this complex number, graphing it like that. Okay, then next we have to what? We have to find now the absolute what? The absolute value. So that is going to be, the absolute value is going to be, now I square, so I'll square, I have 28 over 5 squared plus negative 16 over what? 5 squared. And this is going to be equal to, so 28 squared, what do we get? 28 squared, that gives us 784. Then over 5 squared is 25. Then there you have plus 16 squared, negative 16 squared is just going to give us positive 256 over 20 what? 25. So I can write this as a single fraction inside there, but still having the root, of course. So this is going to be equal to square root like that. Okay, so this is going to be over 25. Then I'm adding what's in my numerator, that is 784 plus the 258. So 784 plus 256, that gives me 1040. So 1040. So this is going to be equal to square root, that's 1040 over 20 what? 25. And this here is going to be square root of 1040 over square root of 25. So 1040 over what? Over square root of 25 there. So what are we going then to get? I'm going to have down there, we will have, so here I'll write my 140 like that, 1040 like that over 5. So now, can we write this? From what we've learned, we know that we can write these radicals as what? As two numbers multiplying. So that on top could be written as what? 4 multiplied by 260. 4, wait, even I think 16 can go into there. So 1040 divided by 16. Oh yeah, 16 can go there. So we use 16. So that is going to be 16. 16 multiplied by what? So 16 multiplied by 65 gives us what? 1040. So 16 is a perfect square, but this is not. Then you have what? 5 there. And this is going to be, so that will give us root 16 over square root of 65 over 5. And that square root of 16 is just 4. Then you have root 65, then over what? Over the 5 there. And that is your answer. Okay, so that is it for today's class. Unless there's any question. May I have any question? Okay. We'll see you in the next one.